Okay, today we'll study about the actually differential equation, ordinary differential equation. This is the previous lecture I am reviewing. Um, Now, what is the definition of differential equation actually? Definition of differential equation: an equation containing the derivatives of the one or more dependent variables with respect to one or more independent variables is said to be a differential equation. That means this equation will consist of one or more dependent variables with respect to one or more independent variables. Now, to understand more and more about differential equation, you must recall the definition of derivatives in from calculus. For any function y equals to f of x, the derivatives of y or f of x with respect to x defined as what? Dx of y can be written as limit h tends to 0, then the functional difference divided by this h length. This ratio can be denoted by with the limit ddx of y. Then this is the definition of derivative, is also denoted by y dash or df dx or f dash x. Okay, this is the actually definition of derivatives actually. In every differential equations, this is the actually differential coefficient or derivatives. This in every differential equation consists of with this differential coefficients. Remember it. That means ddx of f or f dash x or y dash or y double dash is second order. If only single differentiation, then this will be what? First order. And if the differential equation consists of second derivatives, then it will be second order. Okay. And if in any differential equation, if they are only first only single independent variable, then that will be ordinary differential equation. Okay. Now, exponential function y equals to f of x, we can write a function y equals to e to the power twice x. Here x is the independent variable and y is the dependent variable. We can find easily the derivatives dy dx of this, right? Okay, differentiation of e to the power twice x with respect to x will be only 2 into e to the power twice x. That means twice y. Okay, so dy by dx equals to twice y. This is a differential equation, right? Just taking differentiation on both sides, we get a differential equation. So differential equation can be found from after derivatives. Now, differential equation that involve dependent variables and their derivatives with respect to the independent variables. Okay, the differential equations are classified in many types. Order and linearity. Differential equations are classified in different types. Actually, there are two main types differential equation. One is ordinary and other is partial. So ordinary differential equation, what will be? The ordinary differential equation that involves only one independent variable are called ordinary differential equation. That means if any differential equation consists of single independent variable, remember it, only single independent variable with respect independent variable is called ordinary differential equation. So there will be single dependent variable and single independent variable. Remember it. The ordinary differential equation that involves only one independent variable are called ordinary differential. So this is the actually example dy dx plus 5y plus e to the power x. This is the ordinary differential equation. D square y dx square minus d dx of y plus 6y equals to 0. D dt of x plus d dt of y equals to twice x plus y. This is also differential equation. So only ordinary. Okay, ordinary or total derivative, same words. This is the ordinary because only single independent variables. Single independent variables. Now partial, what will be? Partial differential equation, what will be? Differential equation that involves two or more independent variables. Okay, two or more independent variables and two or more dependent variables also are called partial differential equation. Actually, partially a differential coefficient will be consist of in the partial differential equation. So del x square y u del square u by del t square minus t 2 del u del t. This is the actually partial derivatives. because partial differential coefficient are involved in those equations. Now, what is the order actually? We started in our previous lecture of differential equations. The order of a differential equation is the order of the highest derivatives found in the differential equations. Understand? This is the actually differential equations. Actually, this is the differential equation of this is the actually second order, because how many? What are the types of differential coefficient? Uh, Highest differential coefficient what? 2. That means second derivative. Okay, this is the second derivative coefficient. So what will be the, or this is the single first single differentiation. Okay, and this is the second derivative, so this is the second order. Understand? Now, from this differential equation, what will be the this is the also first order because only single derivatives, and this is the second order because what? This is the actually 2 times differentiation, uh, consists of 2 times the differential coefficients. Now, what is the linear or non-linear differential equation? Actually, to uh, nth order differential equation can be written as like this: f of x y y dash dot dot y to the power n. Actually, there are in a single independent variable. Remember it. This is the single independent variable, and with respect to, there are actually many times differentiation up to n time differentiation, right? Y to the power n means actually nth differentiation of y with respect to x. This equals to, actually this is linear in the variable what? This, and this can be written as like this: nx the nth differentiation of y with respect to x, n minus 1, this is the coefficient of n minus 1th differentiation of y with respect to x, plus dot dot how many, and decreasing the order of differentiation, and dy dx last. Then at last we get only the function y. Okay, that be constant will be a naught, a1, n minus 1 dot dot. This may be constant or function of x only. Okay, and this equals to, in right hand side, g of x. This is also function of x. There are no multiplication among the dependent variables and their derivatives. All coefficients are function of independent variables. That means function of x only. Okay, then these types of this is the standard form of linear differential equation. A linear differential, ordinary differential equation is one that is not linear, that it does not have the above form. Okay, now actually why this is, what types of this differential equation we are classifying as linear or non-linear, whether linear or not. That means linear first order differential equation, uh, second derivative d square y dx square and 2 dy dx actually plus y equals to 0. This is the actually second order differential equation. And this was the first order, and this is the actually second order differential equation, and this is the third order differential equation. Now this differential equation actually 1 minus y into dy dx, actually this is the actually first order, plus 2y y e to the power x. Coefficient depends on y, actually, right? Coefficient depends on y. The non-linear first order differential equation, this is the actually non-linear first order differential equation, because we are multiplying with y, right? Coefficient depends on y, right? Dy dx depends on what? Function of y, right? Dy dx depends on function of y. This is why it is non-linear first order differential equation. Now observe the second one, d square y dx square plus sine y equals to 0, and this differential equation actually non-linear function of y, because this is the sine wave, sine function, wave function, and if any differential equation involves exponential function, a logarithm, curve, ln, a log, and sine, tan, cot, etc., then that will be of course non-linear. In any term, if any term of differential equation consists of these types of sinusoidal function or exponential function or logarithmic function, then those types of differential equation is called non-linear, must be. Okay, so non-linear second order differential equation is. Now third one, actually third one for types of differential equation, actually this is non-linear fourth order. Fourth order why? Actually highest derivatives how many? 4. 4 derivatives plus y square equal to 0. Power not 1. That means y square, right? Y square means what? Actually multiplied with y coefficient multiplied with y. This is why it is also non-linear differential equation. So just looking over a differential equation, we must know about order, about degree, about linearity and non-linearity. Okay, I hope this lecture will help you to understand better about the differential equation. Now actually this sine function and cos function, why not non-linear, right? This function actually this is the power of independent variables. Okay, cos y equals to also many powers. This is the actually non-linear, and this is we must know about this curve. This is not linear. Now solutions of differential equations, we also studied about the solution of differential equation in our previous lecture. Now just we are overviewing our previous lectures. Now definition of solutions. Solutions of an ordinary differential equations, any function pi defined on the interval I and possessing at least n derivatives that are continuous on I, which when substituted into the nth order of differential equation reduces to the equation to the identity, is said to be solution of the differential equation on the interval. Yeah, this is the actually reference.
স্যার লেকচারগুলো বাংলায় বললে ভালো হয়, ইংলিশে একটু বুঝতে অসুবিধা হচ্ছে।
হ্যাঁ, solution of an ordinary differential equation. Now actually verification of a solution by substitution method. Okay, verification of a solution by substitution. Example, d square y dx square, right? This second derivative, second order, y double dash minus 2y dash plus y equals to 0. Y equals to x e to the power x. Now actually y dash equals to, then means first differentiation equals to x e to the power x plus e to the power x. Okay, then y double dash what will be? Taking differentiation first, y equals to x into e to the power x is the solution of this. Okay, now differentiating this, y equals to x into e to the power x, taking differentiation on both sides, y dash equals to what will be? UB method, x into differentiation of b plus b into differentiation of u. That means x into e to the power x plus e to the power x will be 1, right? Now taking another differentiation, double differentiation, y double dash what will be? This is also UB method, x into differentiation of e to the power x plus e to the power x into differentiation of x, that means 1, and this is differentiation only e to the power x, so twice e to the power x. Now in left hand side, if you put this values, y values, y dash values, y double dash values in left hand side, actually right hand side 0. That means this is the actually solution of this differential equation we verified. Now the definition, solution curve, a graph of the solution of a differential equation is called solution curve or an integral curve of the equation. Okay, actually y equal to x into e to the power x is the solution of this differential equation. This is the second order differential equation, and we have verified that y equals to x into e to the power x is the solution of this differential equation, because this all term putting in left hand side of this differential equation satisfied. That means left hand side equal to right hand side, verified. Okay, so this is actually, this can be represented as a graph of a solution. We can represent it by using MATLAB or using another software, Python or C++, etc. Y equal to x into e to the power x can be represented as what? Curve, and this is called actually solution curve or integral curve. All right, this is the main words. Actually families of a solution. What are the families of solution? A solution containing an arbitrary constant represents a set z, x, y, c. C is the actually constant and x, y are the involved variables, y is the dependent variables, and x is the independent variables, and this whole function represents the solution of a set of a solution of ordinary differential equation called one parameter family of solution. Actually family of solution because if it's an nth order, then it will be it consists of nth constant, n times of constant. So n number of constant. If it is second order, then it will be only consist of two constant. This is why it is called one parameter family solution. A solution to an nth order differential equation can be written as like this, just for nth order. Since the parameter can be assigned to an infinite number of values, an ordinary differential equation can have an infinite number of solution. Okay. Now verification of solution by substitution method. How we will verify? Actually, this is the first order differential equation, y dash plus y equals to 2. This is the actually dy dx, and this solution. So if you find out solution by variable separable method, of course we get phi of x equals to 2 plus k into e to the power minus k. You can try it at home, just variable separable method. We have studied it in our previous lecture. Phi of x equals to 2 plus k into e to the power x. This is the solution of this differential equation, right? Now y dash plus y equals to this. This is the given differential equation, and phi of x will be this, and phi differentiation of this function phi x equal to minus k e to the power x. So if we take this plus this, phi of x and phi dash x can be take only two represent, right? Only two. That means if we take the sum phi dash x, differentiation of x with respect to the differentiation of phi with respect to x, phi of x plus phi, just taking sum, we are getting what? Right hand side. Understand? That means this represent left hand side. This is the if we draw the curve, we can get this like this. Okay, for different values of k, 0, 3, minus 3, 6, and minus 6, we can draw this curve. Okay, if you are interested, you can draw this curve. Y, this is the curve of what? Y equals to 2 plus k into e to the power minus kx. For different values of k, we get different values, a different path of curve. This is the actually family of curve, right? How many there for k, in depending on values of k, there are n number of there may be a number of curves, right? This is why family of curves, and this is the integral curves, right? Integral curves of y dash plus y equals to 2. Now we can verify another solution by substitution method. We get y dash equals to y by x plus 1 equals to this is x ln x plus cx for all value of x greater than 0. This is, we can taking differentiation, we get this. Okay, taking differentiation ub method, what will be? X into ddx of ln x, plus ln x into what? ddx of x. That means we get ln x plus 1 plus c, and this is the only c after differentiation. So we can write this differentiation like this: x ln x plus cx divided by x plus 1. So this whole above, that means numerator x ln x plus cx means what? Actually phi x. So phi x divided by x plus 1, right? Phi x divided by plus 1. So it can be represented also in a curve for depending on depending on many constants c 0, 5, 20, minus 6, minus 10, etc. We can draw this curve. Second order differential equation. For the second order differential equation, y double dash, this means second derivatives plus 16x equals to 0, and this is the actually solution. This is the solution of this differential equation. By substituting this, that means differentiating, first differentiation will be this of the solution phi x, and second differentiation will be this. Then you can take phi double dash x plus 16 phi. That means look like what? Left hand side. So this function can be written as f of xy, y first differentiation, second differentiation. So y double dash, that means what? Actually, second order differential equation can be written as like this, and also solution space will be this. Now this is the actually second order differential equation, y double dash plus 12x plus equal to 0, and this can be solved by variable separable method. First differential integrating on both sides, we get this, and again integrating to free of differential coefficient, we get y equals to this, and this is the actually solution of this differential equation. You must know about this. There are two constant. Why? Actually, this is the second order differential equation. So if the second order differential equation, then the solution must contains with two constant. If the third order, then three constants. If the fourth order, then four constant. The solution will be consist of what? Four constant. If nth order, how many constant will be in solution? And time. That means n number of constant consist of the solution. To determine C and K, we need two initial conditions. Okay. If we want to find out this C and K, then we must assign initial conditions. Without initial conditions, we cannot find out the value of CK. One is specify a point lying on the solution curve, and the other is at the slope of the curve. That means if x equals to 0, then y0 equals to k, and first differentiation at 0, that means origin is, that means y equal to c. Now this is the solution. If you try x equal to x1 and x equal to x2, that means arbitrary constant. Okay, x1 will be this and x2 will be this. It cannot be determined c and k. Okay, so only initial conditions can be assigned to find the constant c and k. If we want to draw the curve of the solution, this will be for x equals to 0 and y equals to k. Okay, ck, for different values of ck, we get the curve like this. This is the actually integral curve or the solution curve of the previous differential equation. Now to satisfy the initial condition y0 equals to 3, that means 0, that means all this family of curves will passes through the origin. Okay, passes through the point 0, 3. This is actually 0, 3, and many solution curves. Actually, this is the actually a curve of this solution, y equals to 2x cube plus cx plus 3 if k equals to 3. Remember it. To satisfy the initial condition, if x equals to 0, then y0 equal to what? 3. And if y dash 0 equals to -1, then the solution curve will look like this. Okay, this is the graph of what? 2x cube minus x plus 3. If you try if you can implement this curve and try to draw the curve using different programs, C++, or MATLAB or Python, anyone you can draw. Now there are three types of solution. One is general solution, another is particular solution, and the singular solution. Now the definition: solution obtained from the integrating the differential equations are called general solution. Just in previous we have seen many examples. We have integrated to find out the solution. Those types of solutions are called general solution. The general solution of nth order differential equation contains an arbitrary constant resulting from the integrating. That means second order differential equation consists of only two constant, and third order will consist of only three constant. This is why nth order will be consist of what? N number of constant. Now particular solution, what will be? Particular solutions are the solutions obtained by assigning specific values to the arbitrary constants in the general solution. If you try to specify some initial some conditions, assigning specific values, that means in previous we assigned x equals to 0. Okay, then we get a solution. In the previous we initial conditions, we have put x equals to 0. That means x equals to 0 and y equals to what? We got 3. We get 3. Then these all curves are passes through that point for this solution curve. So this is the particular solution. Now singular solution, what will be? Solution that cannot be expressed by the general solution are called singular solution. That means only single solution can be expressed and can never be represented as a general form. The solution can never be expressed as general form. So those types of solution is called singular solution. Okay. Okay, today is the end of the class. Now we will start from linear differential equation tomorrow.